Good evening, everybody. I just want to talk about this week's discussion question. The topic: scientific notation. Scientific notation is used to represent very large and very small numbers in a way that is easy to interpret. For this discussion, use research. Okay, so you're looking things up to identify two quantities or measurements that exist in real life, one very large, one very small. Give the context for the number with units of measurement. Provide a formal citation for your source of your information and an active link for online sources. Write each of the quantities or measurements in decimal form, expanded form, and scientific notation. So you have to rewrite the number in all three. All right. Your citation may not be a textbook or online resources that are teaching about scientific notation. So they're looking for you to find a number written in scientific notation in something outside of the scientific notation lesson. You may cite a textbook or online resource that are referencing the quantity or measurement in another context. You then have to look at two classmates' posts and check them for accuracy. Are there any errors? What did you find most interesting in their posts? What can you add to each one's post about the choices that will further inform your classmates on scientific notation, skills, and concepts? All right, so there you see the rubric. Initial post is added, submitted early in the session before Thursday, and participates on multiple days. So tonight's Monday. If you get it up by Thursday, there's the 16 points. Ideas are clearly stated, include the use of the equation editor for mathematical symbols and notation. All right. So make sure you know how to do that. When you write in scientific notation, it should be an exponential form with the power of 10. Initial response, well written, no grammatical answers. All right. Answer the question or is relevant to the topic in discussion and initially includes the vocabulary of the module. All right. So we're looking for powers of 10, that kind of thing. Makes reference to information found in the textbook or the module with appropriate citations. Response to classmates. Responded to at least two classmates. Do not simply reply with good job, I like what you said, or I agree. So what we're looking for is something to the terms of what you learned from your classmates' posts or what they could learn from your interpretation of what they're saying. So in other words, instead of just saying you helped me, explain what you didn't get about it and how it assisted you in having a better understanding. And then you see the rest of them. All right. Now, one of the things I wanted to give you an idea of what you can use, all right, is, all right, this idea of, all right, where's my OCC file? Right. Scientific notation, big and small. Here's what I was looking at when we were, okay? So the federal government ran a deficit of 3.1 trillion in fiscal year 2020, more than triple the deficit for the fiscal year 2019. This year's deficit amounted to 15.2% of GDP, the greatest deficit as a share of the economy since 1945. All right, so this is in billions. In 1981, all right, this was Reagan, 79 billion, 128 billion in his years. All right, compared to 3.1 trillion. Now, these are prefixes: trillion, billion, million. All right, I want you to look at something like that in terms of, okay, how is scientific notation better than these words? All right, in describing it. So, for example, like trillion is 10 to the 12th. Billion is 10 to the 9th. Why is that a better idea, perhaps, for some people in being able to compare those numbers? All right. Go in the other direction for size. How large is a single coronavirus particle? We're all living in it. And when I looked it up, it said the virus particle size ranges from 70 to 90 nanometers. All right. Well, what's a nanometer? Well, what is the size of 1 nanometer? A nanometer is a unit of measurement for length, just as you have with meters and centimeters. A nanometer is 1/1000th of a meter, or 10 to the negative 9th meters. All right, now you don't necessarily use this, please. You have to go out and get your original one, but this is the idea we're looking for. All right, why would scientific notation be better and to allow us to compare numbers? All right, so that's what we're looking for you to do. All right, so coming back to here. All right. So that's what we're looking for this week with the discussion question. Make sure you pay attention to those rubrics. All right, and we'll go from there. And that's due Try to get it in by Thursday to get those points, but it's due by Sunday. All right, take care and have a good day.